These are the 8-1 notes. You should have your textbooks open to page 471. We learned about what a monomial was last chapter, and we're going to start talking about factoring. We already know what factoring is. We're just going to take those two things and combine them. We know how to factor a whole number, which means to write out all the prime numbers that make that number. So like for 32, we could say that's the same thing as 16 times 2, which is the same thing as 8 times 2 times 2, and then 4 times 2 times 2 times 2, and then that's 2 times 2 times 2 times 2 times 2. So if we did that, we would say 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. You're just finding the prime factorization of that number. That's the same thing as 2 to the 5th power. Now if I come down here, I have negative 20. Automatically when you have negative numbers, you just rewrite it as negative 1 times the positive number. And then we can start factoring it. That's the same thing as negative 1 times 2 times 10, negative 1 times 2 times 2 times 5. All of these are prime, so you would say negative 1 times 2 squared times 5. So we can use the same process when we're talking about monomials, which usually have variables in them. Factored form is when a monomial is expressed as the product of prime numbers and variables and no variable has an exponent greater than 1. Okay, so let's take a look at these examples. I have negative 20 x cubed y squared. So I'm going to rewrite this as negative 1 times positive 20 times x times x times x. X cubed is just x times x times x. And then times y, that's y squared. Now the only thing I have left to do is to factor the 20. So negative 1 times 2 times 2 times 5. I'm just taking that from up here because we've already done that one. And then times x times x times x times y times y. And that's the answer. That would be the factorization of that polynomial. Now let's come down here and do this one. I have 34, which is the same thing as 2 times 17 times x to the 4th, so x times x times x times x is to the 4th power, so I should see 4 of them, times y times y times y for y cubed. 2 and 17 are both prime, so we're done. Turn to the next page. Sometimes 2 or more whole numbers may have common prime factors. Like take a look at the one before. If we have 32 and negative 20, they did have common factors. They had 2's in common. The product of the common prime factors is called the greatest common factor, or GCF. We can find the GCF of 2 or more monomials the same way that we find it for whole numbers. Let's try it for 30 and 50, and then we'll try it for a monomial. So first thing we have to do is find the prime factorization of each of the numbers. So I'm going to say 3 times 10, which is 3 times 2 times 5. Then I have 5 times 10, so 5 times 2 times 5. I'm going to rewrite this so all the 5's are in the same place. So I have 2 times 5 times 5. I can do that because of the commutative property. So to find the greatest common factor, you compare the ones that they have in common. So they don't have any 3's in common. 30 has a 3, but 50 does not. So we're not worried about that one. Now let's talk about the 2's they have in common. But they both have 1, 2. So you can take that 1, 2. And then they each have 5's, but the one that has the most, it has 2. We can only take the ones that they have in common, so they only have 1, 5 in common. So we take what they have in common, 1, 2, and 1, 5, and we find their greatest common factor, which would be 10. So now let's try 12a squared b squared c and 18ab cubed. The prime factoration of 12 would be 2 times 6, which is times 2 times 3. So 2 times 2 gives me 4, times 3 gives me 12, times a times b times b times c. Now for 18, I have 2 times 9, or 2 times 3 times 3. And then I have times a, times b, times b, times b. Now we just take the things that they have in common. So they have 1, 2 in common. They have 1, 3 in common. They have 1 a in common. They have 2 b's in common and no c's in common. So we take the things that they have in common and multiply them. So we have 2 times 3 times a times b times b. 2, 3, a, b, b. 2 times 3 gives me 6. A is by itself. B times b gives me b squared. 6ab squared is the greatest common factor of these two monomials. Turn to the next page. Let's do one more together, and then you're going to try some examples on your own. So I have 6xy cubed, which is 2 times 3 times x times y times y times y. And then I have 2 times 9, or 2 times 3 times 3, times y times z. Take the things they have in common. They have 1, 2 in common, 1, 3 in common, no x's in common, 1 y in common, and no z's in common. So we have 2 times 3 times y, so I get 6y is their greatest common factor. I want you to try the next two examples on your own. Pause the video, come back when you're ready. So I have 11a squared b, which is just 11 times a times b, and then 21ab squared. 21 can be split into 3 times 7 times a times b times b. Okay, they don't have any numbers in common, but they do have 1a in common and 1b in common. So a times b, or ab. All right, 30q cubed r squared t gives me 3 times 10, or 3 times 2 times 5, times q times q times q times r times t. 50q squared rt gives me 5 times 10, or 5 times 5 times 2, times q times r times t. Okay? Circle the ones they have in common. They have no 3's in common. They have 1, 2 in common, and 1, 5 in common. They have 1 q, 2 q's, 1 r, and 1 t. So we take the things they have in common. They have 5 times 2 times q times r times t. So I get 10 q squared rt. That would be my greatest common factor. Go ahead and turn to the next page. This is an example of the kind of word problem that you might see. It says, a florist has 20 roses and 30 tulips to make bouquets. What is the greatest number of identical bouquets she can make without having any flowers left over? How many of them will she use in each bouquet? First thing we have to do is find the greatest common factor of each of the different kinds of rose or flowers. So I have 20 roses and 30 tulips. So we're going to start by finding the greatest common factors. So prime factorization of this would be 2 times 10, which is 2 times 2 times 5. And then I have 2 times 15, which is 2 times 3 times 5. Take what they have in common. They have 1, 2 in common and 1, 5 in common. So we take those times each other to get the GCF 10. That's the number of bouquets that she can make. Okay. Now, to find the number of flowers in each one, we just simply have to look at the ones that she's using. So we're using 2 and 5. Oh, I'm sorry, hold on. We're using, oh, I got confused on that. Just hold on one second. I got it figured out. So she has 20 roses. She's using 2 for every bouquet. Oh no, I'm sorry. She's making 10 bouquets. So that means she's using 2 roses per bouquet. Okay? So if she uses 2 roses for 10 bouquets, she'll use up to all 20 roses, because remember, she doesn't want to have any leftovers. So then for the tulips, she has 30 tulips. She's making 10 bouquets, which means she'll use 3 tulips per bouquet. So 3 times 10 gives me the 30 tulips. She has no leftovers. So that might have been a little bit confusing, but that should give you an idea of what you're going to see on for your homework for word problems. To find out how many bouquets she can make, we found their greatest common factor. And then to find the number in each one, we said she has 20 roses. She's making 10 bouquets, so she should use 2. Same thing for the tulips. She has 30 tulips. She's making 10 bouquets. She should have 3 tulips per bouquet. That's the end of the 8-1 notes. Go ahead and take a look at your homework, and I'll see you tomorrow.